Okay, let's talk about the laws of log. There are a few laws that you need to remember and they'll be helpful. We know that exponents law, when bases are same, powers can get added. And when bases are the same and it's being divided, we can subtract the powers. We can also multiply our powers if our base is the same. For log, when the base and your value are equal, it's equal to 1. Log base b to the power to 1 is 0, where b can be anything. Log base b of b to the power of n is just n. Okay, so these are your log laws, and then there are more. Log base a m times n will just be addition. You'll add them, and when you're doing m divided by n, it's gonna be subtraction. Log base a m to the power of n, we're just gonna bump it and it'll be n log base a of m. Okay, let's try using these log rules. We are given an expression and they're asking us to convert it into a single log. Now if you remember the bumping rule, we're gonna do that. Log x to the power of 2 minus log c 2 plus bump this again, so we get log y to the power of 3. Now this 2 right here that's given to me is we cannot bump it, right? But if I write it down as, let's say, log z and half times, then I can bump it and it'll just be log square root of z plus log y to the power of 3 plus log x to the power of 2. Oh, that's minus. So now when you subtract the same log base, it's going to be x squared divided by z. Add something, it is going to be y to the power of 3. So my answer is going to be, oh, this is z, writing things down weird, but that's how you'll solve this question. Okay. Let's try this question. They have given us the log function where y is greater than 0 and x is greater than 0, has to be right, and y is equal to what? So let's try figuring this out. So we know log base 3y c minus log base 3z. Let's bring all the logs to one side. But we need to isolate our y, right? So what we'll have to do in this case is log base 3y. Now 1 times c. Remember, if you have 1, you can have log b base b, right? In this case, it'll be beneficial for us to have log 3 base 3. So we'll do c times log base 3 and log 3x, which is just gonna be, if I bump it up, it's gonna be log 3 to the power of 3c minus log 3x, which will be, when we have same logs, it's going to be 3c over x, right, which is equal to log base 3y. Now because we have the same thing, y is going to be 3 to the power of c over x, which is option D. Okay, let's look at this question. When a to the power of log and a to the power of log are being multiplied, and we do simplify it as an expression a to the power of m, what will the value of m be? Now bases are the same, powers get added. We have 3 log base b to the power of 4 plus log b to the power of root b. Now in this case, my log bases are the same, right? And this radical always scares me, so I'm just going to write it down as a fraction. So a 3, and let's just get rid of a, because we know that all this is basically equal to m, and we need to find our m value. So log base b root 4 can be written as 1 over 4 log b to the power of 4. Sorry, b to the 1 to the power 1 over 2. 1 over b. Oh my god. Okay. It is 1 over 2. Yeah. Anyways. So, if you remember the rule in which they said log b to the power of b of b to the power of n will just be n, we're just going to use that and get rid of this. So 3 times 1/4 plus half is going to be 3/4 plus half is equal to 3/4 plus 2 over 4, which is 5/4. Okay, and now you put that in the calculator, it should be 1.25, and that's how you write it. Okay, that's your answer. Let's do the next question. So they have given you I'm just also trying to look at the answers if they're correct. Oh, this is confusing. Yeah, okay, that's correct. Okay, now we have two log functions, and they're asking us to find out the value of log 2x times y. Now, because it's x times y, you guys, it's gonna be, if we open that up using a log rule, we are just adding it, right? Now, the main concern we have over here is that there are some trig things given to us here, right? So let's find out the value of that first. It's 0.5, which is half for this one. So log half y is equal to -1. And then we have cos pi 2, which is, oh sorry, pi over 4, which is 1 over root 2. X is equal to 2. Okay, so none of our bases are the same. What should I do in this case? Well, I can ask myself, can I find out what my value of x is? Like, can I convert this as an exponent? Well, you can, right? So it's gonna be -1 to the power of half is equal to y. Okay, and this is gonna be 2 to the power of, oh no, I did this wrong. Our base stays the same, so it's going to be half to the power of -1 is equal to y. So it's going to be, when we have -1 as a power, 2 is equal to y. Okay, now for our x, it's going to be, base is the same, it's this, the power of 2 is equal to x, and when we do that, we get 1 over 2 is equal to x. So we can simply put our values in here. Okay, so when I do that, things are a little messy here. Let's see if I can just move this. Okay, so log 2 half plus log 2 2, we know same base in the thing is going to be 1, and log 2 1 half is going to be -1. So that means my answer is going to be 0. Okay. A lot of questions here. Okay, log base a is given to us, which is good. A lot of questions is good. I think you guys should try this question on your own. It's a little bit complicated than this one, but like it's a good question to try on your own. You basically have to substitute things in, so try it yourself. Question 39. So they're just asking us to write the relationship of log. This is easy, right? All you need to do is subtract log m to the other side, and you're gonna get 0 is equal to log a plus 3 log m l minus log m. So it's gonna be a, and this can be bumped up, times l to the power 3 over m, and we keep our log like that, and done. Oops, doesn't look right though. What did I do wrong? Oh, they have reversed it, right? I know what they did. So I know this did not work, but basically if you look at this, instead of moving or subtracting minus log m on both sides, all we need to do is subtract like that. So we're subtracting negative log a minus 3 log l on both sides, and we'll get log m minus log a minus 3 log l is equal to 0. So it'll be log m divided by a log l3, because take that, and that's equal to 0, which is option A. Basically reverse of what we did. Okay. This question looks scary, but let's try doing this. All you need to do is, if you can just put in your value like in the calculator and solve it, it would work, because none of your bases are the same. So you cannot use the log laws over here, but you can put it in the calculator. Now remember, log base cc is 1, and anything log base anything a was 0, right? So just remember that, and other than that, you guys should be good for this question as well. Let's look at the mistakes in this person's work. So let's play close attention. Okay, he bumped it. 4 times 2 is 8. Bumped it again, 6. Yeah, 4 times 3 is 12. Looks good. Now bases are the same. It's important to look at that. This is being divided, but then this was being multiplied, so it should have been times x to the power of 12. Unfortunately, that was the mistake. Make sure you don't make that mistake, and it's gonna be step 3 where the mistake happened. Okay.